Now that we have the basic reducers in place, we need to start dispatching some actions and actually handling those actions in the appropriate reducer. And to do this, we're going to be exploring a very handy ES6 tool. It is the ES6 spread operator, and it's going to make it a lot easier to work with arrays and objects. We'll talk about that a bit later. For now, before we can actually add anything into the reducer, we should probably set up an action generator and actually dispatch an action. So right here, we're going to start off with the add expense action. I'm going to create an action generator. It'll be a function stored under the add expense variable. And right here, we are going to implicitly return the action object. We know we need a type, and I'm going to set the type equal to add expense. Alongside of type, we're going to have the expense object. The expense object is going to contain all of those fields we need: ID, description, note, amount, and created at. The last four are going to come from the user. The first one is going to get generated by our code. To generate a unique ID, there's a library we're going to use. So we're going to be setting ID equal to, and to get the ID, we'll be using the NPM library, UUID. So if I Google NPM UUID, it should bring us over to the right place. Here we have the UUID package. This is going to allow us to generate those universally unique identifiers. And this is exactly what we want. So all we have to do is install it and call the function, and we'll be able to generate those IDs. Later on, they'll come from the database. For now, this is going to be a great alternative. I'm going to switch back to Expensify, and over inside of the terminal, we are going to need to install this new library. So I will be shutting down the dev server and using yarn add to add it. It's UUID, and the most recent version is 3.1.0. I'm going to go ahead and add this dependency. Once it's added, I'm going to restart the developer server. Then we'll be able to actually use it. So once the dev server is back up, we can switch over to Chrome, switch over to the editor, and right here, we're going to import it. Now there's a single default export we need for this library. So we're going to import UUID from UUID. And we just call this to generate a random ID. So right here, I will call UUID. I'm going to call it, and I'm going to take the value that comes back and set that equal to the ID value. Now, where do the other four things come from? Well, they come from the user. So that's going to get passed in, and we're going to be using the same setup we used over here to destructure the values and set up defaults. So it's going to look very similar to this. Over here, we are going to destructure the first argument. If it doesn't exist, we will destructure an empty object. Then on here, we can define all of the things we actually want to grab. First up, I'm going to go ahead and grab description. Now, description is going to need to get provided by the user, but we can also allow for an empty description. So right here, I could always go ahead and set that equal to an empty string, and the same thing will be true for note. We want the value provided by the user. If there is none, an empty string will suffice. Next up, we have the amount. We can default the amount to an appropriate value like 0. And last up is created at. For created at, we can pick a good default. And for the moment, we'll just go ahead and use 0 until we talk about timestamps. Now this line is pretty long. We can always reformat this to be a little more readable. I can put a new line right after the opening parenthesis and before the closing one, and I can even break up this object onto its own line as well. So I can take each property, moving them onto their own lines, and in the end of the day, I do get something a bit more readable. So this is the format we can stick with for some action generators. They're a little more complex. Now that we have all of the correct values coming in, all we have to do is attach them to the expense object. We're going to be using the property shorthand. So I'll set up description, then we will set up note, then amount, and finally we have created at. So now we have the add expense action generator completely set up, and we can go ahead and actually add an expense. So down below, I'm going to do just that. I'm going to do it right below where the store gets defined, right here. I will be using a call to store.subscribe to track changes. Every time the callback function runs, I will just print this line to the screen. So I'll move that line inside of subscribe, making sure that we get notified of those changes. Now we're going to be using store.dispatch to dispatch something. In this case, that something comes from the add expense generator, and we pass an object into this. Now we don't have to provide all of those values outlined. For now, I'm just going to provide a description. I'll set description equal to rent, And I'm also going to provide an amount. So right here, I'll set amount equal to, and I'll go ahead and use $1, which would be 100 pennies. I can toss a semicolon on the end, and there we have it. We've successfully dispatched an action. But the question is, what happens? How exactly do we handle this when we're using combined reducers to set up multiple reducers for the Redux store? Well, it works just like it did before. The dispatched action, the action with the type add expense, it is going to get dispatched to both reducers. So it's going to get dispatched to the expenses reducer and to the filters reducer. What we're going to do, though, is just set up case for the reducers that actually need to do something when add expense gets dispatched. Does the expenses reducer need to do anything? Yes, it needs to add that to the array. Does the filters reducer need to do anything? Nope. Adding an expense doesn't affect this data at all. So we're not going to be adding a case for add expense. We're just going to leave that case off. It is going to run the switch statement, and the end result will be the default case running, in which case the state won't get changed at all. Up above, we will be setting up case, however, so right here we can get that done. Case. This particular case is looking for an action type of add expense, and when we see it, what do we want to do? We want to run some code that adds the new expense onto the array. Now at this point, we know that state is an array, so we might be tempted to use state.push to manipulate the array. We want to push on a new item. We stored that on the action object. It was action.expense. The problem with this is that push changes the original array. And remember, we want to avoid that. We don't want to change state or action. We just want to read off of them. Luckily for us, there is an array method that lets us do that. It is concat. So we're going to swap out push for concat. And this takes the array here and combines it with the item over here, returning the new array. It doesn't change state at all. So now we can go ahead and actually return the result. And this is going to work as expected. We can go ahead and save Redux Expensify right here. We have our store. On the expenses array, we have a single item. It's an object, and everything on that object is looking great. We have the amount we set. We have the default value for created at. We have the description we set. We have the default value for note, and we have a random ID generated for us by the UUID library. All of this is working because we successfully handled add expense up here and used concat to return the new array. Now this works, but what I want to explore is something called the ES6 spread operator. It's going to allow us to get the same thing done and more. We can mess around with the spread operator over inside of the browser console. So right here, I'm going to go ahead and create a variable for an array. I will call this one names, and I'll set it equal to an array with a couple items inside of there. I will use Andrew, and I will use Steve. So we have these items inside of names, and now let's say we want to add a new item on without changing names. Now if we use names.push, that is going to change names. If I add on Jen in this way, the return value is the new length, and if I look at the names variable, we can see the item was actually added on, which means that names was changed. This is not what we want. If we want to add an item on, we can use concat. So I could use names.concat. I can then concatenate on something new like Julie. And when I do that, I get the new array back. And this time around, we can see that names wasn't changed. Now, aside from concat, we can use the spread operator. So let's go ahead and look at that. To use the spread operator, we're going to explore a very strange syntax. So we're going to go ahead and create a new array. We are going to spread out all of the items on the current names array. So just bear with me for the moment. That is going to be ... names. Now this syntax looks very strange. Essentially what it says is, hey, as we create this new array, I want to add all of the items from names right here. So if I actually run this statement, which is completely valid, the end result is an array that matches the previous one. We have Andrew, Steve, and Jen. If I want to add a new item on, all I do is add it in like I would for any other array. If I want to add an item on after those names, I can toss it right here. I'll toss Mike on, hit enter, and now we can see we have Andrew, Steve, Jen, and Mike. But the cool thing is the spread operator didn't change names. If I look at names, names still doesn't have Mike. Now we can create more complex arrays with the spread operator as well. I could say that I want to add a name up front. Let's go ahead and use Adam. And then I want to take all of the values from names. And finally, I want to wrap things up with Mike once again. So what's going to happen here? We're going to have Adam. Then we're going to look at names, which has Andrew, Steve, and Jen. Finally, we'll add Mike on, and that is exactly what we get. Adam, Andrew, Steve, Jen, and Mike. So the spread operator is great. It allows us to create new arrays from old ones, and we're going to be using this exact same approach over inside of our application code. So what we're going to do right here is return a new array. We're then going to define the items that go in that array. We're going to start off with all of the existing items from the array. So ... state, we're going to spread out all of the current expenses. And then we're going to go ahead and add on the new item right here. That is the action.expense object. This has the exact same effect we had before. If I go ahead and save the Redux Expensify file, over here we still have the expenses array and it still has our one item inside. We could also go ahead and add multiple expenses by adding multiple dispatch calls. I'm going to go ahead and copy that line, pasting it down below. This time around, I will buy a coffee that costs 3 times much as my rent. Right here, I will use $3 or 300 pennies. And if I go ahead and save the file, we would expect it to dispatch twice. We would expect 2 items to be added onto expenses, and that is exactly what we get. Right here, we have the rent expense, and down below, as the second item, we have the coffee expense. Now, coffee comes after rent because up above, we say, hey, take all of the current items, then afterwards add on the new one. And now that we have the add expense case all taken care of, you're going to go ahead and set up remove expense. So we're going to be removing expenses by their ID. Now there is one piece of information you need before you can get that done. If we're removing expenses by their ID, we need a way to actually get expenses by their ID. Now, yes, we do get that information back from store.getState right here, but we actually also get the action object back from store.dispatch. So if I dispatch an action object, it comes back as the return value from the call to dispatch, and we could just create a variable that stores it. So const expense 1, for example, and then down below, we can make a const for expense 2. Now, what exactly do these variables equal? Well, we can find that out by just dumping them to the screen. Console.log, I will dump expense 1 to the screen. Now I can go ahead and actually save the file and see what we get back. And right here, we're just getting the action object back. So we have the type add expense, which we set up. We have the expense object on there. We have all of those properties. The one we need is ID. We need this in order to actually remove the expense. Now I will give you the function call right here, and it'll be your job to actually create the action generator and fill out the reducer part. So that'll be a call to store.dispatch. We are going to be dispatching an action object that'll come back from remove expense. So that'll be one thing you create. We're going to pass to remove expense an object, and on this object, we're going to set ID equal to the ID of the expense we want to remove. Now we are going to require the ID, so there will be no default value right here. Expense1 dot expense dot ID. So this is the exact call we need down below, and the end result is that we should go from 1 item to 2 back down to 1 as we remove the first item. And at the end of the day, the only expense we should have left is going to be coffee. It's going to be your job to actually get that done. So up above, you are going to need to create the remove expense action generator, and you're also going to need to wire that up inside of here. You're going to have to handle the remove expense case, and to create this new array, you're going to be using filter. We used filter in the previous project, the indecision app, to remove an item by ID. So if you forget how it works, you can always refer back to that. Take as much time as you need to get that done. When you are done, make sure you're just seeing the one expense the final time the state prints. We should just see coffee. Take as much time as you need, pause the video, and when you're done, click play. How'd that go? I'm going to kick things off by creating the remove expense function all the way up at the top of the file. Right here, const remove expense. This is going to be an action generator, so we'll just make it an arrow function that implicitly returns an object. Perfect. Now what type do we need for this? We need a type of remove expense. And we also need some data. So we're going to get an object passed in as the first argument. We're going to destructure that object. If it doesn't exist, we will just destructure an empty object. And we're going to be pulling off ID, no default required. Now this ID needs to make its way onto the action object. Otherwise, we can't use it in the reducer. So I'm going to go ahead and just toss that on right here. Now that we have ID and type both set up, we actually are going to have an action successfully dispatched. All we have to do is actually handle remove expense down here in the expenses reducer. So I'm going to set up a new case. This case is looking for remove expense. And when we see remove expense, what do we want to do? We want to return a new array. Now I mentioned that I wanted you to use filter, something we've done before. So we're going to use state.filter to get a new array back. Remember, state.filter doesn't change state. Filter doesn't change the array it's called on. It returns a new array with a subset of the values. That is exactly what we're looking for. So right here, we will pass in the function. If this function returns true, the item will be kept in the array. If it returns false, the item will be removed. We're working with an array of expenses here, so the individual item could be called something like expense, and we actually just need the ID off of there, so we could even go as far as just destructuring the expense and getting ID. Now what's the goal? The goal is to return true or false based off of a condition. We are going to check if the ID is not equal to the action ID. If they're not equal, this will result in true, meaning the item will be kept. If they are equal, this will result in false, meaning that that expense was a match and it needs to get filtered out. Now we could simplify this further. We have an arrow function that just returns some expression. So I'm going to go ahead and take the expression, cut it out, remove the curly braces, and paste it in right here. And there we go. We now have the code set up to generate the remove expense action object and to handle it in the reducer. If I go ahead and save this file over in the browser, we go from one expense to two expenses back down to one. Over here, I can see I have my rent expense and my coffee expense. And in the last one, I should just have coffee. And that is exactly what I have. Rent was removed because we took the ID, we dispatched the remove expense action, and in the end of the day, everything is working really well. We now have 2 of the 3 cases handled for the expenses reducer. In this video, you explored the spread operator when working with arrays. In the next one, we're going to explore how we can use the spread operator with our objects as well. That's going to make it really easy to edit expenses, and it's also going to make it much easier to handle these 5 actions related to our filters. That is all coming up next, so stay tuned and I'll see you then.